Welcome to Module E, Lecture 7. In this lecture, we shall talk about Logit choice model. Of course, Logit choice models also do include or Logit choice models are also included under disaggregate choice models, but specifically since we are going to discuss about Logit choice models, I made the title as Logit choice models. But Logit choice models are also under disaggregate choice models, particularly disaggregate probabilistic choice models. What we discussed in lecture 6, a quick recap to that. We discussed about the difference between the true utility and the utility specified by the analyst. We said that analysts have certain limitations. So, whatever we take in the model, that utility may not be the true utility. There could be several reasons which we explained. So, there will be a difference between the true utility and the utility specified by the analyst. We gave you several examples to show that how the specific utilities and the true utility could be different and what are the error terms in corresponding examples. And then we said then the true utility is deterministic component of the utility plus an error term which accounts for all these missing components, and this error term is unobserved and unmeasured and follow certain random distribution and is a random variable of course. And what the analysts can consider is the deterministic component of the utility. And then we explained to you with an example or rather a set of examples that the dependence of, we explained to you through a set of examples, the dependence of choice on the deterministic component. The deterministic component of utility for an alternative increases. So, the probability of choosing that alternative will increase. The deterministic component of an utility decreases. So, there will be a reduction in the probability of using that alternative. So, that dependency we explained to you with a set of examples. Now, with this background, let us continue our discussion, and we are now going to be more focused on Logit models. As I said, Logit models come under disaggregate models and disaggregate, particularly disaggregate probabilistic choice models. Now, let us go back to this error term. There are many things, but a few things quickly we shall try to discuss. Now, this error term is what? It is a random variable. So, it follows certain distribution. Now, what distribution we are assuming, depending on that the type of model will be decided. So, first of all the error terms are unobserved and unmeasured, which could be represented by a wide range of distributions. So, if we consider that this error term of each alternative represents many missing components, not one, but many missing components, and each of which has relatively little impact on the value of the each alternative, then as per the central limit theorem, we can say that sum of all these small errors will follow a normal distribution, right. So, one possibility is of course to assume that this error term, this random variable follows normal distribution, and normal distribution is very common, right. So, anything commonly to be assumed in all such cases, it is basically the normal distribution. And if we assume that this is error is normally distributed and it follows a normal distribution, the variable, then it will lead to the development of multinomial probit model MNP. So, one thing from this slide, if the error term, if we assume that it follows normal distribution, the random variable, that is the error term, then the model will be basically multinomial probit MNP. But MNP is not so popularly used in real life or in practice, because the mathematical complexity of MNP makes it difficult to estimate, interpret and predict, which has limited the use in practice. So, MNP models, it is not that MNP models are not developed. I have also developed in various works MNP models, I have used it. There are some specific contexts where MNP model performed better even, but generally not so popular because of its complexity in the estimation. So, what is that other alternative? The other alternative is, if we consider that this error term or the random variable is extreme value or Gumbel distributed, then this formulation will be multinomial logit MNL. So, two types of logit model, multiple types of logit model are there. In this one we shall discuss binomial logit, multinomial logit, and also towards the end a little bit introduction on the nested logit model, right. So, but you know that fundamentally the difference between logit and probit is due to the assumption of the distribution of the error term. So, specific assumptions which have led to the development of multinomial logit models are: first, the error components are assumed to be extreme value or Gumbel distributed. Second, error components are assumed to be identically and independently distributed across alternatives. Third, error components are assumed to be identically and independently distributed across observations or across individuals. Observations come from individuals, right. In this case, it is the behavioral data that we collect and we try to analyze. So, we can think that this is the error components are identically and independently distributed across observations or individuals. So, across observations and or individuals also they are identically and independently distributed, across alternatives also identically and independently distributed, and the distribution follows extreme value or Gumbel distribution. That led to the development of multinomial logit or logit category of model. Okay. Further, you will see it could be binomial logit, multinomial logit, nested logit. Further, other types of developments are there, which we will not discuss here in details, but a very popular widely used model, at least I have used that formulation in several works, not one work, but several works. That is the random parameter logit model or mixed logit model, but which we will not discuss in this course. So, now a quick look at how the probability density functions look like for normal distribution and Gumbel distribution. You can see the thin line is representing the normal distribution and the thick line is indicating the Gumbel distribution. So, how the PDF or the probability density function looks like. Similarly, I have quickly shown you that how the CDF or the cumulative distribution function looks like for normal and Gumbel distributions. They are not very different, there are definitely lot of similarities, and that is why people make it. Okay. I do not consider it normally distributed, but I consider the distribution as Gumbel distribution, right, and then make it computationally a little easier for estimation and application purpose. So, I am not going into further details, because there is little bit limited scope for touching on different topics. Let us come to the properties of probabilistic choice model. When we said you that it is basically the analyst limitation, and not only the limitations. Remember that error terms include what? Sometimes it may be that it is the limitation as analysts, that I know that something influence the choice behavior. I know that I should include that, but I cannot include, maybe because the data is not available. That is one component which takes care, which is taken care by the error term. Second is, I know that it influence, but I do not want to include them, because I cannot predict. I said the health impact. Somebody is not feeling one day, somebody has got some urgent work on one day. Even if suppose while developing the model, I collect the data meticulously from each and every person and try to say, look at the calibration part, I considered all such kind of influences as relevant variables, but and to make my model very good, right. But how to predict it? Can I predict it? And as I said that repeatedly, I am saying the model you develop not for the base year, you want to apply it in the future. So, any variable what you are using in a model, you should be able to predict those variables in the future. So, anything if I cannot predict, and if I cannot predict accurately or reasonably accurately, always there will be some certain error. Even in any variable you consider in a model, you will still be approximate, right. But at least approximately we should be able to predict, right, or in a realistic manner we should be able to predict. So, if not, then we do not consider. The third is that I even do not know that something influenced the choice decision. So, there was no scope for me to even consider that. So, all such kind of things are taken care by the error term, and the distribution of error, what distribution we assume for the error term, that will determine whether it will be logit or it will be probit. Now, let us with that one, let us look quickly at the properties of probabilistic choice model. There are 4 properties of that probabilistic choice model, desirable property I should say. 1, the probability of choosing a particular alternative should depend on the relative values, carefully observe, relative values of deterministic component of utilities of all alternatives. Utility of an alternative depends on the values of that alternative only. It does not depend, car utility does not depend on what is the value of travel time by bus. But what we are saying, the probability of choosing car or choosing a particular alternative should depend on the relative values of the deterministic component of utilities. Deterministic component of utilities is something which we can quantify, which we can measure, of all alternatives. What is the probability that people will use car will not only depend on the deterministic component of utility of car, but also will depend on the deterministic of utility of drive alone, not only drive alone, but also carpool, also bus, or in a real situation if you have got also metro operating, then metro will also come, all alternatives, right. So, we have to consider. Property 2, the probability that an alternative is chosen should increase when the deterministic component of its utility increases. This in a way we have shown you in our previous lecture. Towards the end we took a combination of examples to tell you, right, that how this parking charges imposed for the drive alone, how the parking charges increases, right, and because of that the disutility increases associated with drive alone, or utility decreases, and utility decreases. So, we have said even in real sense the probability of using car also decreases because the utility decreases, right. So, same is true in the other way, right. So, if you think in a reverse way that the parking charge was 30 rupees, right, now it becomes 15 rupees, now it becomes free of cost, what will happen? The utility will increase. So, obviously, the results will be in a reverse direction. You will find the probability of using car is increasing as the utility is increasing. So, utility increases, the probability of choosing that alternative increases, utility decreases, the probability of choosing that alternative decreases. But also the other part, because what we said, relative values of deterministic component of utilities of all alternatives. So, there is an interdependence. So, what will happen? The probability of choosing an alternative will also decrease when the deterministic component of the utility of another competing alternative increases. So, let us say A, B and C. So, utility A increases, probability of choosing A will increase. Utility of A decreases, probability of choosing A will also decrease. But if the utility of B or C increases, then also probability of using A will decrease. That is what I say, that it should also decrease for a particular alternative, say A. If the deterministic component of utility of any other alternative, say B, increases. So, if B increases, the probability of using B will increase as per the first statement. So, obviously, probability of using A will reduce. Fine. Third, the model should accommodate choice sets containing any number of alternatives. I should be able to handle, my model should be able to handle 2 alternatives, 3 alternatives, 4 alternatives, any number of alternatives, and also can be used to predict the effect of changing the number of alternatives. Fourth, the model should be easy to understand and use in practice. Ultimately, practitioners will use these models. So, we should make the model should be such that one can easily understand and use it in practice. So, all these 4 properties are desirable properties of probabilistic choice model. Now, let us go to the binomial choice Logit model. The word binomial means what? It immediately tells you the number of alternatives is 2. There are only 2 alternatives. So, it is frequently used model of probabilistic choice among 2 alternatives. And as per binomial Logit model, what is the probability of using alternative 1 is equal to e to the power v 1, v 1 is the utility, deterministic component of utility for alternative 1, divided by e to the power v 1 plus e to the power v 2. So, numerator includes exponential of the utility of that alternative, deterministic component obviously, and the denominator includes e to the power v 1 plus e to the power v 2. So, this will give you probability of using alternative 1. That is the very fundamental formulation. Now, 2 things will be of interest here. One is to understand, we are saying exponential of utility. So, we should be able to feel that how the exponential value, exponential function changes as the utility changes. So, if the value v changes, how e to the power v is changing. Second, how this change in v 1 and v 2 will reflect the probability, how the probability will change because of the change in v 1 and v 2. We shall slowly try to understand those. Before that, if I have to say what is the probability of then choosing alternative 2, obviously we will say there are only 2 alternatives. So, probability of choosing both alternatives should be either this or the other. The total probability of making a choice should be 1. So, probability of choosing alternative 2 is 1 minus probability of choosing 1, that is what we have done here. And you will see that means probability of choosing alternative 2 is e to the power v 2 instead of v 1 in the first case, because that was alternative 1. So, used e to the power v 1, here it is for 2. So, it is e to the power v 2 and the denominator remains same, e to the power v 1 plus e to the power v 2. That is what we get as well. Now, as I said, I have plotted this approximately, this is of course approximate, to give you a feel how the exponential function looks like. I am saying if my v is changing from minus to plus, or when the value of v is increasing, we say exponential function, how really the e to the power v changes. You can see that as values are increasing, there is a significantly it is the exponential value is increasing, and how, at what rate and how the changes happen, that is very interesting. Okay. So, it is just for you to feel that when you are saying e to the power some utility, taking utility and taking e to the power utility, it makes a lot of difference, right. This is the exponential function. The second is binomial Logit model has 3 of the 4 desirable properties. We said about 4 desirable properties just a few minutes back. Now, you see that there are 3 properties which it is able to satisfy. First, the binomial Logit choice probabilities depends on the deterministic components of utilities of alternative. Yes, in the equation you have e to the power v 1, also you have e to the power v 1 as well as v 2 in denominator, and the numerator e to the power v 1 or e to the power v 2, depending on what probability we are trying to find out. So, but probability of choosing one of these 2 alternatives depends on the utility of both alternatives, right, in the equation. So, the first property is satisfied. The probability decreases when the deterministic component of the utility of other alternative increases. Go back, simply see this equation. Suppose v 1 increases, so probability of choosing that alternative increases. So, utility of alternative 1 increases, naturally exponential v 1 will increase, right. So, overall the probability of choosing 1 will increase. But if the other alternative, if v 2 increases, what will happen? v 1 does not change, v 2 change. When v 2 is increasing, what will happen? Probability of choosing 1 will decrease, right. So, the second property is also satisfied. Third is not satisfied, it should be able to take any number of alternatives, only it can take 2 alternatives, that is the third property is not satisfied, but the fourth property is satisfied. I am sure if I could explain you correctly, it is not difficult to understand and difficult to apply as well. So, you can easily understand, you can calculate the deterministic component of utility given that utility equation, and you can apply this simple model as I have shown to get the probability. So, it is property 1, property 2, property 4 are satisfied, property 3 is not satisfied, because it can handle only 2 alternatives. Now, what we can observe here, the choice probability is more sensitive to changes in the deterministic component of utilities when these components are approximately equal. what will happen? E to the power v1 divided by e to the power v1 plus e to the power v2. So, if my v1 and v2 both are same, then what is the probability? Probability of choosing each alternative is 0.5. Now, interestingly, at that level, if any change in utility happens either for alternative 1 or alternative 2, then the change will be very significant in the probability. But as you go far away from this midpoint where both are equal, as you go far away, right, the change in the probability due to change in the utility is going to be smaller and smaller. Now, one more interesting thing, just simply take the equation, this basic equation e to the power v1 divided by e to the power v1 plus e to the power v2. So, if I divide both the numerator and the denominator by e to the power v1, what I get? I get then 1 by 1 plus e to the power, take the minus outside, v1 minus v2. This is very important and you must remember this always. What it is saying, generally because it is something in numerator, something in denominator, the probability is the ratio of something, unknowingly we tend to think it is the ratio of v1 and v2 that is controlling the probability, which is wrong. You see here, it is the difference in the utility value that is controlling the probability, not the ratio. It is nowhere the v1 by v2 comes into picture. It is v1 minus v2 that is controlling the probability. So, let us take when v1 and v2 is equal 0 0 and say v1 minus v2 is 0, then probability of using each alternative is what? 0.5. Both utilities are same, logical, very logical, right. If utilities of two alternatives are same, what you expect? 50% people will use this and the 50% people will use the other alternative, that is what is quite logical. Now, as it changes, now the difference become 0.5, difference become 2, 2.5, right, and how the probability is changing. So, now it is the time for us to see how the probability changes with the difference in v1 and v2. Let us do that. That is what I have shown. See, it looks like a S curve. This is a very interesting and very realistic thing. You will find in many contexts, you will find this curve is valid. This is one of the really most beautiful way of representing the things, right, very realistic way of representing the thing. What will happen? Say, take the simple thing, you have bus and train, equal fare, equal all other travel time, all attributes, for the moment let us consider them as identical. You only same fare. So, what will happen? 50%, 50%, 0.5, 0.5. Now, you little bit make one more, maybe make the rail little cheaper, what will happen? A lot of people will try to shift to rail. Now, if you keep on increasing the fare, progressively you will find lesser and lesser people are shifting. For the first change, how many people have shifted? Next increment of the same amount, not so many people will shift, little lesser. And as you went, so you make a toll road, increase the toll, make the toll very high, still it will not be 0. Still some people will use it. Okay? Maybe the probability will come down, but it will not become 0. Also, it will not become 1. Right? Because there are other factors, there are error terms, there are other considerations. Right? So, how the maximum change will happen around 0.5 probability, or when the utility of two alternatives are equal, and as you go away the impact will become lesser and lesser. Now, the probability of choosing, as I said, alternative 1 is more sensitive to the change in the deterministic component of utility of either alternative when P 1 is close to 0.5 and than when P 1 is close to 0 or 1. Obviously, very insignificant change will happen when it is close to 0 or close to 1. Maximum will happen when it is 0.5, and I explained it why it is so, why it matches with the real behavior. It very well matches with the real behavior. P 1 is affected equally by the increase in the value of V 1 and decrease in the value of, if I increase V 1 or if I decrease V 2, the effect is going to be same. Why? Because it is the difference V 1 minus V 2. The difference will matter. How much is the difference? The difference may come because of the change in V 1, the difference may also come because of the change in V 2. It does not depend on where the change is happening. It is basically the relative value, that means the basic difference in V 1 minus V 2, that is controlling. So, with this what we discussed in this lecture, we discussed about various assumptions in error term which led to different model formulation. Normal distribution led to the development of probit. Gumbel distribution led to the development of Logit. We said that due to mathematical complexity, MNP is not so popular or not so used widely. We also said that what are the desirable properties of the probabilistic choice model, and then we showed you what is the formulation of binomial logit model, what are its properties, and we say that binomial logit models satisfy 3 of the 4 desirable properties. Right. So, we close it here. We shall continue this discussion in the next class and talk about multinomial logit model. With this, I close this lecture. Thank you so much.